describing a distribution with numbers. We've talked about this using SOCS, shape, outlier, center, spread. We're going to start off using the center. We're going to start off with measures of center. We have two different measures of center we're really concerned with, is the mean and the median. Yes, mode is in there, but we don't use it quite as often. So why do we have two? Is because distributions come in infinite types of shapes, so one will help it describe it better than another. If you have data that is symmetrical, you want to use the mean, and you have data that's out skewed or has outliers, you want to use a median. So what is the mean? The mean is the average. And how do I find the average? Hopefully you've done this before in your life. You simply add the numbers together and then divide by how many there are. So in this case, if I had 4 plus 10 plus 5 plus 6 plus 5, all divided by 1, 2, 3, 4, 5, that would give me 6. The formula you'll see on the AP sheet looks like this: 1 divided by n, the number of pieces of data, the summation symbol, x to the I. You also may see it written like this: x to the I, the summation, x to the I over little n. Little n means number of pieces of data in our data set. When it's little n, it usually means, and it doesn't usually mean, it means it's coming from a sample. If it's big N, it comes from a population. X sub I just means I'm totaling all my x's. The median is the middle number. Well, how do I find my middle number? Is I'd have to put my data in order first. So I would do 4, 5, 5, 6, 10. And then I have 1, 2, 3, 4, 5 pieces of data plus 1 divided by 2. We'll say go to the third piece. So I count the number of pieces of data, add 1 divided by 2, go to the third piece. My 1, 2, 3, 1, 2, 3, you can count either way, would be 5. So my median is 5. Now if I had an odd, even, that's if I have odd. If I have an even amount of data, let's say I added 12 on the end here, and I put them together, 1, 2, 3, 4, 5, 6, 6 plus 1 divided by 2, it's 3.5. So that means it's between the third and fourth piece, which is right here. It's not really a piece of my data, so what do? I add 5 plus 6 and divide by 2. I would get 5.5. So that's my median. My mode, which number occurs most often? Well, if I look at my data set, 5 occurs the most often, so therefore my mode is 5. If I had another 6, it would be 5 and 6. As soon as I go to 3, I'd say no mode. So we're going to use our same data set, and this time we're going to do measures of spread. There's 3 measures of spread, the same way there were 3 measures of center. And the first one, the easiest one, the one that we'll start with, is the range, which is simply the largest data point minus the smallest. So 10 minus 4, which gives me 6. That's all there is to the range. Sometimes when people write range, they'll do 10 minus 4 equals 6, so someone could see, because 6 doesn't mean as much. It could have been 100 minus 94, but if they do 10 minus 4 equals 6, they'll see what it is, but the range is 6. The next thing we're going to talk about is IQR, and IQR is going to be Q3 minus Q1. You say, well, what's Q3 and Q1? Q3 and Q1. Q3 is the median of the upper half of my data, and Q1 is the median of the lower half. So if this was my original data set and this was my median, all I do is find the median of the upper half and the median of the lower half, then subtract them. That'll give me my IQR. So the median here, well, I only have 2 pieces of data, so it's going to be the average between those two. That's Q3, which the average of those two is 10 plus 16 minus divided by 2 will give me 8. The average of these two for Q1 is 4.5. So my IQR is going to be 8 minus 4.5, which is equal to 3.5. Standard deviation is the one that takes a little bit of time. The formula, it's little s x, you'll see this on the AP sheet, is equal to the square root of 1 over n number of pieces of data minus 1, summation xi minus x bar squared. So what I do is I take each piece of data and subtract it from the mean, square it, divide by number of pieces of data minus 1, take the square root. And that's how I find standard deviation. There's a button for this on the calculator. You'd have to do this one time. I'll show you quickly if I have my data 4, 5, 5, 6, 10. What I would do is take each piece, subtract it from the mean. So it's 4 minus 6, which is negative 2. Square it, I get 4. 5 minus 6, negative 1. Square it, 1. So then this one's 1 right below it. 6 minus 6, that's 0. 10 minus 6 is 4. 4 squared is 16. So I total these things, and I will get 22. Divide by n minus 1. There's 5 pieces of data, so I divide by 4, take the square root, and I'll get an approximation here. And my answer was 2.3. It's approximately 2.35. That's the typical distance each piece is away from the mean. That's what standard deviation is. So standard mean and standard deviation go together whenever we have a set of data that is symmetrical. IQR and median, they're linked forever. They go together when you have extremely skewed data or data has an outlier. Then you'd use median and IQR. If I'm going to use standard deviation and mean, the data would be symmetrical. A lot of times when you have a stem plot, it may not show much when you have a lot of data in the same spots. So what they do is split the stems at times. So I'm going to split my stems. I will go 0, 1, 2, 3, 3, 4, 4, 4, 6, 6, 6, 7, 7, 1, 2, 3, 4, 5, 9, 1, 2, 3, 1, 2, 2, 2, 3, 7, 8, 9, 20. Oh, did it again. 9, 24. So when I have data and I split, you can look at the previous screen. I split it up so it looks like this. My data is skewed to the right. And if I want to find the 5-number summary from this, which it's the 5-number summary is, I want the min, the median, I want Q1, Q3, and the max. These things allow me to draw a box and whiskers plot. So min's easy. It's the smallest number. Smallest number in this is 0. Largest number, that's 24. The middle number, well, there were 31 pieces of data. So I do 31 plus 1 divided by 2, 32. I go to the 16th piece. Count in 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 right here. It's this 8 here is my median. So there's my median is 8. Q1, Q3, what do? I find the median of the lower half, median the upper half. There's 15 pieces of data plus 1. 16 go to the 8th. 1, 2, 3, 4, 5, 6, 7. Right there is Q1. Q1 is 8, 4, 4. Then go 1, 2, 3, 4, 5, 6, 7, 8. This one is 12. Q3, 12. And I'm going to use these numbers to create something called a box and whiskers plot, which will be on the next one. From the previous page, I copied the 5-number summary, and I'm going to create something called a box plot. I used the 5-number summary. At 0, I had a minimum, so I put a dot. At Q1 I had 4. I put a line. You'll see the scale that I drew down below. It doesn't have to be perfect. The median was 8. Q3 was 12. And the max is 24 out here. Another dot. So this is what a box plot looks like. I use dots to represent the min, max. This is min. This is max. This is Q1. This is the median. And this is Q3. So that's what we use to write it. You don't have to write those on there. You just draw it just like this, represent it this way. The only other thing I need to check for is if this is an outlier, I must show that it's an outlier. How do I know if it's an outlier? I have to use the formula of 1.5 times the IQR. And then I take that number and I subtract it from Q1 and I add it to Q3. So I do Q1 minus 1.5 times IQR all the way up to 1.5 times IQR plus the Q3. So that creates something called fences. And anything that falls outside those fences, we would consider that an outlier. If you have an outlier, you use a dot to represent it. And then the next highest point goes to the end. And you'll see on the next slide, I have an example of one with an outlier. So the formula, it's not real clear here. Q1 minus 1.5 times the IQR all the way up to Q3 plus 1.5 times the IQR. This slide shows you what it would look like with an outlier. This is an outlier. This point here is the next highest point that's not an outlier. Next highest data point that's not an outlier. This isn't from our data set. I just used this to create one that would have an outlier. The formula again for outlier is I take Q1 1.5 times the IQR. 1.5 times the IQR, and I do 1.5 IQR, and I do Q1 minus that. Q1 minus 1.5 times IQR all the way up to Q3 plus 1.5 times IQR. That creates fences. Anything that falls out creates a range, which we call fences. Anything that falls outside of that, you consider an outlier. When they tell you to show your work, to show something that's an outlier, you have to show this work here. You have to know this formula. Our calculator will create one that looks like this with the outlier, but you have to understand where it came from and why something is an outlier. That's it for today. Thanks.